Hello, good afternoon to all. Hello, yes.
Good afternoon, sir.
So, shall we start?
Yes, sir.
Yes, sir. Please start.
So, yesterday that already you have discussed about the upper oscillator and also the bracket that's the positive feedback condition, and also the same thing. Same time we consider the brackets and criteria. So, today we'll discuss the per type of oscillator. So, in this actually you can discuss the per different type of oscillator. So first of all, there are quite many types of oscillator, but actually they can be broadly classified into two main categories. One is called harmonic oscillator, and the other is called the part relaxation oscillator. So in harmonic oscillator, basically that we can find the energy flow is always from the active component to that of the passive component, and the frequency of the oscillations are decided by the part feedback path. But in case of the relaxation oscillator, the energy is exchanged between the active and the passive component. So here the transference of energy takes place from passive to from active to passive. But here you can find there is for some for actually exchange that takes place between the passive and the active component. Okay. So for the harmonic oscillator produces low distortion sine wave output, while the relaxation oscillator generate non-sinusoidal waveform. So this is the basic difference between the harmonic oscillation and that of the part relaxation oscillation. Now we can talk the first audio frequency oscillator. Okay, so this is also type of oscillator. This oscillator designed to provide an output signal over audio frequency range, so which are known as the part audio frequency oscillator. And the oscillator, this oscillator allows to measure the circuit gain and compression at any frequency. The audio frequency oscillator is designated to provide an output signal over audio frequency range, and the laboratory audio frequency oscillator provides frequency range from 10 Hz to 100 Hz approximately. So if you can discuss about the block diagram, you can see this is the part block diagram shows the part that this is a sinusoidal wave oscillator which have a part frequency range selector. So what is the frequency that you want to give? Then this is coming to the part connected to amplifier. So you have already discussed about amplifier. So which may produce a part a sine of the part square wave. Then it is get connected. It's also connected to the part micro that wave shaping network like clipper or clamper circuit. Okay, and then it is get connected to the part attenuator and frequency counter, frequency display, and finally that we can get the part output here. So this first block is that of the sine wave oscillator. This one, these oscillations are of the part wind bridge or the phase shift type. They produces a pure waveform. Okay, and however, when the output voltage required is large, then beat frequency oscillator is preferred to generate the part audio frequency signal. Okay, and the design and the use of the beat frequency oscillator is actually quite a complex one. So the oscillator will provide with a frequency range selection, which so this have a frequency selector is there. Okay, switch for the part core frequency, and there is a part fine frequency range or fine frequency control also provided, and the output of the sine wave oscillator goes to the part amplifier here. Okay, so this is the first part of the part block diagram. Similarly, for coming to the part second part, you can see the amplifier amplifies the signal generated by the oscillator, and the amplifier is provided with a negative feedback to maintain the stability of the part operation. You can see, so this is the part actually. Uh, so whatever the output is coming, so here you can get the part of feedback to the part input here. Okay, then so a voltage follower circuit is also used to provide very high input impedance, very low input current, and very low output impedance, and unit gain for the amplifier. And this voltage follower will be the final stage in the part amplification section, and the amplifier output goes to the part attenuator through a part switch. The switch is select the sine wave output direct from the output of the amplifier. Then we are by setting the part switch to the in position, it will connect the part output to wave saving network of the part attenuator. The wave shaping network is supplied from the output of the amplifier, and the sine wave is shaped to a wave, two-way wave, square wave in output of the wave shaping network, and the attenuator has the part code. So this is the describe the part, the different part of the part, this block diagram. Okay. Now we are coming to the part, another is called the part RF oscillator, radio frequency oscillator. Okay, and this radio frequency oscillator actually is defined the part electronic circuit which produces a part periodic and oscillator part signal. Okay, and the RF frequency oscillator is known to convert the direct current originating from the power supply into an alternate current signal. Then the RF oscillators are also primarily characterized by the output frequency and the phase noise of the per generator signal. And the basic working principle of the oscillator can be explained by simple concept part LC circuit or tank circuit behavior. So you may have the ideas about the part LC circuit. So due to the part oscillations of the part LC circuit, we can get a part RF. So RF frequency actually RF oscillator basically it's coming to a part Hartley oscillator, Colfield oscillator. So this oscillator that you may have read. Okay. So then you can find also part just you can see here. So these are called actually the part, the different type of part, the linear oscillator, which is part actually, based on the part this radio frequency range. Okay. Now you can come in the part relaxation oscillator. So I told all the part relaxation oscillator where there is exchange of the part energy takes place from the component to that of the part, the passive circuit, the passive component, and it is produces a part non-linear signals or the waves. Okay, and relaxation oscillator define the part nonlinear electric oscillator circuit that can generate the part non-sinusoidal respective or a repetitive output signal. Okay, so if you can see the part, this is the part non-generative or the part non-periodic. These are the called simple for yes non-linear output here. Okay, so the design of the relaxation oscillator must include no, that is non-line element like transistor, op-amp, and also the or MOSFET and energy storage device like capacitor or the part inductor. Okay, so then you can find actually yes, then the to produce a per cycle, the capacitor and the inductor charge you can find charge and the discharge continuously, and the frequency of the cycle or periodic oscillation depends upon the part time constant because this is a simple RC circuit. So you must find there is a part the time constant factor is also affect many in many cases. The relaxation oscillator incorporate the energy storing device such as capacitor and inductor, and the shape of the output waveform relaxation oscillator depends upon the time constant of the part RC circuit. These things also that we are already we have told here. Okay, then you can find this is the part output that coming from the part relaxation oscillator. Here that you can find the capacitor connected between the part ball. You can see in the ball and the part battery. Okay, and here you can also find, and this circuit also known as what flasher circuit or the RC relaxation oscillator. Then a battery charge the capacitor to the part resistor. So here you can find the battery is upper charge to the part this capacitor charging. Okay, during the charging the capacitor, the bulb remains in off condition. When the capacitor reaches its schedule or threshold value, it is discharged through the bulb. Okay, and thus the during the discharging of the capacitor, the bulb is part growing. When the capacitor is part discharged, it starts charging by the source again, and the ball remains a part off condition, for which you are getting a part a zero state condition. But when the capacitor again goes on charging, then the ball is part close, okay, and again this will be goes on for discharging. So like that part, it the repeated the cycle is part operate or the process is for going on, and the discharging glowing of the part valve goes on part takes place. So the charging time of the capacitor is determined by the part time constant, okay, and the flashing rate of the bulb is determined by the part value of the resistor and the part capacitor. So this waveform across a bulb are shown part in the this part diagram actually. Okay. Now, so this is the part of the different type of oscillator like you have discussed actually relaxation oscillator like RF oscillator and also part audio frequency oscillator now. Okay. Now, I'll be discuss to op-amp. Is the slide is visible? Hello,
Yes, sir.
Yes,
Visible.
sir, it's visible.
the slide is visible.
Yes, sir, it is visible clearly.
Okay. Now we come to the part case of the part this operational amplifier or the in this operational amplifier you have read the part basic features, characteristics, and also the part applications. Okay, and also you can find the part different applications of the part this op-amp here. Okay, so what is an operational amplifier? Operational amplifier, or in short we call op-amp, it is an integrated circuit which can be used to perform various linear, nonlinear, and mathematical operations. An op-amp is a direct coupled high gain amplifier. It can operate with both AC and the DC signal. It is a multi-stage DC coupled amplifier with a very high gain and also the part temperature stability. So these are all the features. Okay. Then the typical device has a differential input, a single-ended output, and a very high gain. Because of its high gain, the output is usually several thousand times the difference between the input and the part signal. However, in most practical applications, the operational amplifier work with external component that provide feedback and direct the part functionality. Okay, so this is the part basic features of the part op-amp. Now we'll go to the part construction of the part op-amp actually. So here you can find, so this is part op-amp and it basically consisting of a part amplifier, a level translator, and also for output. So these are output, the input here. Then this is the part simple part, a translator, level of translator, and then you can get the part output. So differential amplifier is present at the input stage of an op-amp, and hence op-amp consisting of the part 2 input terminal. So as you have the part 2 input, okay, that we must also we have the part 2 input terminal here, and that is the part one of those terminal is called inverting terminal and other term is called non-inverting. So the terminals are named based on the phase relationship between their respective input and output. You can see in the diagram this V plus is simple termed as a part non-inverting, okay, and this V minus is for simple inverting input here. Similarly, V output is output, Vs plus is a positive power supply, and this is the part negative power supply. So this is the part basic configuration of a part op-amp actually. Now types of op-amp you can find. So an op-amp is represented with a triangle shape having two input and one output. You have seen op-amps are two types basically. One is called ideal op-amp and the other is called a practical operational amplifier or op-amp. So, so though it may be for ideal, but it is not the part the same for exact sense of ideal. Okay, an ideal op-amp exists only in theory, but not practically. So that is why we discuss actually the practical op-amp actually, which are really operating in a circuit. The equivalent circuit for this ideal op-amp is part shown here. You can see an ideal op-amp exhibit the following characteristic, like its input impedance is part infinity, output impedance here you can find this is zero, open loop voltage gain that is a part infinity. Then if the input voltage Vi is equal to 0 volt, then the output voltage also part 0 volt here. Okay, so bandwidth is what I told yesterday also bandwidth. So bandwidth is for infinity and it remains or it means, so infinity means it means an ideal op-amp will amplify the signal or any frequency without any attenuation. And here you can find one common rejection ratio, CMMR ratio is for to be infinity, okay, and slew rate also for infinity. It means the ideal of op-amp will produces a change in the output instantly in response to that of the per input step voltage. So this is the part some characteristic of a part ideal op-amp here. Okay. Now we'll be discuss actually mainly will focus on the part practical op-amp. So practically op-amp are not ideal and deviate from that their ideal characteristic because of some imperfections during the part manufacturing. Okay. So the equivalent circuit for the practical op-amp is what shown here. You can see here the input impedance, here is the output impedance, and also for output here. So practical op-amp exhibit the following characteristic. It has some for input impedance in the order of some mega ohm. So in case of ideal, it has infinity, but here you can find some mega ohm. Output impedance also part not input has from the part few ohm, and open no voltage gain AV will be also part very high here. Okay. Now, when you can choose a practical op-amp, you should check whether it satisfies the following condition or not. Okay. So first of all, you can find the input impedance is part S should be high as possible. Then output impedance also you can find that is ZO should be part low as possible. Then open low voltage gun AV also you can find that you can find is a part high as possible. Then output offset voltage should be low as possible. The operating bandwidth should be part high as possible. Common mode rejection ratio should be part high as possible. Slew rate should be part high as possible. So these are the part some of the characteristics that must be associated with any practical op-amp. Okay. Now, so what is the effect of this characteristic on op-amp applications? So I just part put it in tabular form. We can see op-amp characteristic that may affect large performance. So for DC amplifier, you can find, so this is you can find small output, and for AC amplifier there is a part large output, and also you can find the part small output here. So input based current you can find small output, this is S. For large output you can find this may be, or for yes, this is part may, and output also is part no. AC amplifier there is a small signal output, that is also no. So these are the part some comparative study, or these are the effect of the part characteristics of some op-amp applications you can find in many cases here. Then how the feedback is actually applied to that of the part op-amp. So let me first talk about part negative. Yesterday also that I have told you. So negative feedback is basically applied to that of the part op-amp, and the other positive feedback applied to that of the part RF oscillators. Okay. So you can find actually here this we often the negative feedback in a op-amp by connecting output terminal. You can see this is the part output terminal to inverting the per input terminal through a suitable resistance. So this the part output is connected to that of the part input resistance here, giving a part a suitable part giving a part simple part is the output the connect to that of the part input resistance here actually. Okay. Now, so in this negative amplifier we have a part actually one of the part best thing is part there. So that is a part you can think. So in this negative feedback amplifier, you can find there's a closed loop gain of the op-amp when we connect the part a feedback resistor and a resistance in series. Okay, so feedback resistor and a resistance in series with the inverting input terminal upon op-amp, the system gain become the negative ratio of the feedback resistance to that of the part input resistance. The op-amp has its own very large gain and ideal infinity. By choosing the appropriate value of the series resistance input RI and feedback resistance RF, we can get the part open loop gain is equal to minus to RF by part RI. Okay, and op-amp is generally used with negative feedback, not with the positive feedback. Negative feedback causes its per gain to decrease substantially. On the other hand, negative feedback increases the frequency bandwidth in which you can find the gain curve remains flat and decreases the per flat of that is output decreases per output impedance. So it also reduces the distortion, noise, instability. This feedback increases the bandwidth and improves the input and output impedance. Okay, then due to these advantages, the negative feedback is frequently used in part op-amp. So this may be a part question why the op-amp is always working with the part negative feedback, not with the positive feedback. Okay, am I clear to all? Hello.
Yes, sir.
Okay. Now I'm coming to the part negative feedback part in op-amp actually. So for the negative, the same things I have already part told you. Okay, and I have written part the some amplification. So op-amp negative feedback find is mainly in amplifier. For the input is part multiplied by a factor, that is called the gain, and the output should be part linear and stable with the part change in with the changes in the part input. Similarly, if you can go for the positive feedback also, that non-inverting terminal, you can see this is also the part non-terminal that you can give the part feedback actually for the from the output here. Similarly, you can find also the part this positive feedback is also applied to that of the but this inverting is inverted terminal. Okay, so the non-inverting amplifier circuit can be modified a little bit to create a part circuit that has the positive feedback. The inverting and the non-inverting input of the part op-amp are switched so that the inverting input becomes the signal input and the non-inverting input becomes the part pin that reverses the feedback from the output to the voltage divider here. Okay, so you can see this is the part, the diagram for the positive feedback op-amp, where you can find the positive feedback is applied to that of the part non-inverting terminal. Now, when the voltage are the input, when the voltage on the input becomes higher here than the voltage on the part non-inverting input here, then output goes actually part low. You see, when you can say the voltage at the input became higher than that of the part non-inverting terminal, then you can find the output goes low actually. Since the op-amp is powered from the part plus or minus 12 volt and the output is part actually minus 12 volt, therefore the non-inverting input is at part therefore minus 6 volt. Okay. Similarly, the output nowadays for is last at minus 12 volt till the input goes below minus 6 volt, of which point towards the part is which output goes high to 12 volt, putting up the part the non-inverting non-inverting input. Okay, so now the part input has a 2 cross 6 volt. Uh, okay, to make the part output change the part gain actually. Unlike I can say the non-inverting or the non-inverting amplifier contains a part uh, configuration. This concept of this does not to maintain equilibrium to the input. Instead, it is saturated for either supply real in the part nonlinear per circuit. So this is one type of part, one benefit that you are getting a part feedback op-amp actually. Okay. Then some applications that I have written, you can see also you can get part here yourself. Okay. Now I'm coming to the part the op-amp to be act as a part the different circuit or different applications, like it may be act as a differentiator, it may be for act as a part integrator. Okay, so like that part it can be used in part many cases. So first let me talk about a part a differentiator. Okay, then you can talk about part simple a part integrator. Okay, so you're finding here. So what is a differentiator? So differentiator is an electronic circuit that produces an output equal to the first derivative of the part input actually. Okay. So whatever the input that we are applying at the part input terminal, you must find actually the part the difference in the part output or the first derivative of the part input. Suppose I put it part y as an input, then the output I can get the part y prime, and that y prime is equal to dy by dx. Okay, so that is called a part differentiator. An op-amp based differentiator produces output which is equal that of the differential of input voltage that is applied to its part inverting terminal. In the above circuit, the non-inverting input terminal of the op-amp is connected to the ground. That means zero voltage is applied to its part non-inverting input terminal. Okay. According to the part virtual short concept, the voltage at the inverting input terminals are op-amp will be equal that of the voltage present in non-inverting terminal and non-inverting input terminal. Okay. So the voltage will be the part inverting and non-inverting terminal of the op-amp will be for 0 volt actually. So the nodal equation that you can see is the part simple. Your part op-amp as a part differential circuit must be part must have to remember. Okay. Now, so from the circuit that you can find actually that is a part that is a CV VQ V by part T. Okay, there is a part energy stored. You can see here. Okay, it's a capacitor. So naturally you can find C D of minus of VI by dt plus a part 0 minus a part V0 by R, which you can find to be 0. So if you can solve, then you must find the output voltage is equal to minus of a part is dVi by a part dV dt actually. Okay. Thus the op-amp based differentiator circuit shown will produce in upper output which is the differential of the per input voltage Vi, and when the magnetic field actually of impedance of resistor and a capacitor are reciprocal to that of the per each other. Okay, and note that you can find this output voltage having negative part sign indicates the part that exists in part 180 phase difference between the input and the part output signal here. So this is the part basic idea about a part simple. If I told the part or differentiator or one of the application of the part is op-amp actually. Similarly, op-amp integrator. So as like the part differentiator, then we can also part get the part as integrator circuit. So an integrator is an electronic circuit that keeps or that produces your part produces an output that is in integration of the part applied input. This section will discuss the part op-amp as a part based integrator. Now, this is a part simple integrator. You can find there is a part capacitor is connected both the part input and output terminal. The base terminal is part grounded, and this part resistor is connected. So, as the circuit shown in the part in the inverting, yes, uh, inverting input terminal of the part op-amp is connected to the ground. That means 0 volts is is applied to spot non-inverting input terminal here. Okay. Similarly, you can find also on a visual short concept, the voltage at the inverting input terminal of op-amp will be equal to the voltage difference present in at the part non-inverting terminal. So that because as here you can find there is a part difference in the for the input voltage actually. Okay. So according to the part this virtual concept that you can find the voltage of the part inverting. Okay, that you can find uh, this is the part virtual concept. The voltage at the inverting input terminal of the op-amp will be equal to the voltage present at its part non-inverting input terminal. So the voltage at the inverting input terminal of op-amp will be for simple 0 volt. Okay, so now if I can put it part in the mathematical form, then I must find the nodal equation at the inverting input terminal. You can find 0 minus Vi by part R actually. So 0 minus Vi. So because you can find this is Vi and this is 0. So I must so it must has to be a part S. It is equal to 0 minus Vi by R plus of C into d0 minus V0 by part dt actually. So if you can solve this part equation, you can get actually the part required output. Okay. Yes. Can I get or not? Tell me. Hello. Hello.
Yes, sir. Yes, sir.
Okay. Okay. See. Then I will go for the part. This is for integrator. So here you can find this is the part differentiator. Then I can go for the part logarithmic part amplifier. How the op-amp can also act as a logarithmic amplifier. As a logarithmic amplifier or a long amplifier or log amplifier in an electric circuit that produces an output that is proportional to that of the logarithm of the part applied input. And this section provides about the op-amp based logarithmic amplifier in details. Okay, an op-amp based logarithmic in amplifier produces a voltage at the output which is proportional to that of the part logarithmic of the part out voltage applied to the part resistor counterpart connected in the inverting terminal actually. So this is actually part a logarithm that whatever the output that we are getting, we must have take the part logarithm decrement so that we may get the part uh, advance from the part electromagnetic wave or that you can see sorry that may be the signal. Okay, that you can also part deserve here. Okay, now this is the part actually part here you can find one part. Yes, you can find actually this is called a part op-amp logarithm decrement part logarithm amplifier. Okay, now so similarly if you can apply the part Kirchhoff's voltage law, the equation around the part the feedback loop of the gain is equal to a part 0 minus Va minus a part V0. Okay, so in this circuit diagram that you can find the non-inverting input terminal of a op-amp is connected to the ground. You can see it's a ground. that means the voltage is applied to the inverting, non-inverting input terminal. Here you can. Okay. Then according to the per virtual support concept, the voltage at the per inverting input terminal of an op-amp will be equal to that of the per voltage at the non-inverting input terminal. So the voltage at the inverting input terminal will be simply for 0 volt. Okay, that we should be careful that we should. So the nodal equation for this logarithmic also you can find. So for total equation, and I got the final equation is found to be what IF is equal to I is equal to what e to the power part minus S VI by a part AVT. So this is the part the power current that what are getting actually. Okay. So as the substitution current of the diode, the voltage drop occurs that of the part diode when it is forward bias, then it is VT is your part your diode thermal equivalent voltage actually. Okay. Then uh, then here you can find one is so after that we're coming to that of the part. Yes, uh, listen student that I think that we have finished this part, the different op-amp and the and the part its application. Now we are coming to that of the part, some converter actually, like a linear mode power supply and also switching mode power supply and their difference. Then ADC to part DC converter, digital to the part binary and also for binary to digital converter, like that. Okay, you can see a type of power supply which consisting of the part linear voltage regulator to reduce the input AC voltage to the desired output DC voltage, that is known as part linear power supply. Okay. Hello.
Sir. Yes, sir.
So actually, I'm just coming to part the last part actually. So all of you must listen carefully because these are all are part the long questions, one on long questions that you may be obtained here. Okay. So linear mode power supply that I told, a type of power supply which consists of linear voltage regulator to reduce the input AC voltage to that of the desired output DC voltage. So that is known as for linear power supply. So linear power supply work by dissipated extra voltage in the form of heat by using linear voltage regulators. Okay. Therefore, they are better suited for the low power application. That means for the low power applications, we can use the part linear mode supply. So linear power supply are simple to design as they have simple electron circuit to directly convert the part high voltage into low voltage here. In comparison to the part switching mode power supply, linear power supply are less efficient due to high power generation. And linear power supplies are commonly used in part application such as lab instrument, okay, then the part analog electron circuit, audio amplifier, and many other low power electron devices. And this figure you can shows the block diagram of the part a typical regulated DC power supply in case of a linear mode power supply here. So this is the part you can see the part is a block diagram of a part linear power mode supply. So the basic building block of regulated DC power supply indicates this is called a part a step down transformer, okay, a rectifier, then you can find a part DC filter, okay, then you can get a part regulator, and this is the part output or the part load here. Okay, so this is the part basic diagram of a linear mode power supply. All of you be careful to this. Okay, then switching mode power supply is part. So this is stands, so SMPS actually stands for the part switching mode power supply, and it is an electron circuit that convert high voltage AC power into low voltage DC power. Okay, for this purpose it employs transformer and rectifier along with the high frequency switching circuit. Okay, then the transformer reduces the voltage level to that of the desired level, and rectifier converts the part AC into DC. That is the part general function that you know. In addition to the rectifier, it also consisting of the part filter circuit. You can see here also a filter circuit. Okay, then you can find so filter circuit is part used to remove the part ripples or that is unwanted signal that is coming to the part input. So a SMPS part also widely used in various more modern electronic devices and such as computer, laptop, communication equipment, and medical equipment, industrial machinery, and many more. Okay, a switching mode power supply is a power converter that utilizes switching devices such as MOSFET and that continuously turn on and off at high voltage. Okay, and energy storage devices such as capacitor, inductor to supply the power during the non-conduction state of the switching devices. Okay, then they are available converting the part universal AC input voltage that range from the part 20 AC voltage to that of the 264 AC voltage and with a variety of popular nominal DC output voltage from the part reputable suppliers. Okay, so these are the part the features that associate the part switching mode power supply here. Similarly, as like the part what you can say actually the linear mode power supply, we have the block diagram of a part switching mode power supply. Here you can find the main components of the part. You can see the supplier have high efficiency up to 90%. That means switching mode power supply can supply the part 90% power. Okay, and you can find also part this is the part the block diagram for a the switching mode power supply here. Okay, here you can find the yes here you can find simpler the part AC input supply here. Then we have the part input rectification and the filtering, then which is get fed to that of the part high frequency switch. Then from that high frequency switch there is a part power transmission. Okay, and from the power transformer that is going to the part out yes output rectification and also the part filtering. Okay, then again at the part same time this we can apply the part yes this is the part is control circuited for power. Okay, so this is the part simple the block diagram of a SMPS here. So basic operation switch for power supply includes the part the main component of the part SMPS are that is the part input rectifier and filter, inverter consume high frequency signal and switching devices, power transmitter, then the for output rectifier and also feedback system and the circuit control actually. So these are the four basic features that are uh, associated with this actually. Okay. Now switching mode power supply is also I've just part written all the things you can read yourself. For this is the part actually some of the basic operations how to convert. Okay, and how it can be changed to ideal. That is actually part written here. Okay, and then I can go to part a comparison. I have put it part in a very tabular form. So these are the parameter, switching mode, power SMS, and also linear power supply. So you can go to the part this 3 to 4 slides. That is where I'm written actually part the comparison between the SMPS and also that's the part your part linear mode power supply here. Okay, I'll not part go to this. You can read the things actually here. So now I'll go to the part simple how we can convert to that of the part the DC to AC converter actually. So DC to AC converter is mainly designed for the part changing of the DC power supply to that of the part AC power supply. Here DC power supply is comparatively stable as we all as well as positive for voltage source for an AC oscillation approximately for the 0 volt stage typically for sinusoidal or square mode. Okay, the common inverter technology you can find actually used in electronics to convert a part voltage source from a battery into an part AC signal, and generally it operates with a part 12 volt and commonly used for applications like automotive, LED AC technology, and photovoltaic cell. A transformer coil system and a switch also part made simple circuit used for the part inverter. Then, so basically, I think all of you may have is a part inverter oscillator circuit in the part form. So this is simple DC to AC converter here. So due to the current flow in the part bidirectional in the primary coil of the transformer, and alternate current signal is an output throughout the part secondary coil. Okay. Then this is a part construction of a part DC to your part AC power supply or AC converter. So this actually consisting of a part DC to AC converter circuit using a part that transistor here. Okay. So this is a part transistor. Okay. Now, the basic function of the part inverter circuit is to generate oscillation with specific specified DC and apply this to transformer primary winding of the part increasing the current. Okay. So this main voltage is then step up to a high voltage based on the number of twists within the main and the part mirror coil. Okay. So here you can find, so depending upon the part twist of the part of this coil, we have the part the different applications here. So this main voltage in the setup is the high voltage based on the number of twists within the part main and the part minor coil. The current, the circuit diagram of 12 volt to that of the part 10 to 20 volt AC converter can be built with using simple transistor. This also part made of simple transistor. Okay, and this circuit can be employed for powering lamp to 35 watt, although they may have they can be designed for driving more influential loads by utilizing the part their MOSFET actually. So this is the part simple block diagram of uh, a DC to part AC converter here. Similarly, now I'll put the part. These are the for some limitation DC to per AC converter. So the transistor uses can reduce the circuit efficiency, and also switching the transistor can cause the part crossover or distortion with the part output signal. So these are the part some of the part limitations. Similarly, it has some also application you can find DC to AC converter used in vehicle to charge the batteries. That circuits may used for driving low power AC modes and used in a part solar power system. They, this is all about the part DC and part AC converter, and there can be part used DC lines of part of transmitting power to load into the to load, and on ininterpretable power supply. Okay, uh, that is the part this can be used to convert a part direct current to part alternate current. So these are the part simple applications of the part DC to AC converter here. Okay, now I'll go to actually the part another part instrument that is called the part the vibrator, or sorry, multi vibrator. Okay, so in this context we will discuss actually the three type of multi vibrator. That is, one is called your astable, monostable, and bistable. But before going to that, so let me first talk about the part astable, sorry, multi vibrator. You know, a multi vibrator is a switching circuit that is a two-stage resistance coupled amplifier with positive feedback from the output of one amplifier to the part input of the other actually. So this is the part basic features of the part simple multi vibrator. Then the name multivibrator derived from the fact that square wave generator consists of a large number of sinusoidal and the different frequencies, and multivibrator as a crucial parts of the digital circuit and computer architecture to sum up. Okay, so they are utilized to data storage, synchronization between the vacuum component, then the clock signal generator, timing control, and the data transfer time. A multivibrator circuit oscillates between the high in state and also part low state and cross state, producing a part continuous output. Okay. Then you can find also in a multivibrator the two transistors are connected in feedback. Okay, feedback, so that the one transistor control the first state of the other actually. I'll come to the part this diagram. You can see this is the part. This is the part simple. The multivibrators are classified in three categories. Each are part like astable, monostable, and the part bistable. And this is the part simple. The part when you can see when you are not applying any input to this astable multivibrator, it can also produce a separate output whatever the signal is applied here. And when you can input after the monostable, you can produce a separate This is the part output, and when a bistable, you can find a part single output with the part different frequency limit actually. So now I'll go to the part actually details actually astable part multivibrator. So the an astable multivibrator is a type of the per electron circuit that produces a continuous square wave. You can see a square wave input is given. It can also produce a per square wave output without any external input actually. Okay. It is also known as a part free running oscillator, or we can simply say a relaxation oscillator, because it switches between the unstable state by itself here. Okay, so the astable multivibrator is one of the three types of multivibrator along with monostable multivibrator and the for bastable multivibrator. So uh, that is why this is actually what termed as a part relaxed oscillator, which can simple exchange the energy from the active that of the passive component actually. Okay, so this is the for circuit diagram. You can see here. Okay. Now, so this circuit simply includes the part 2 identical transistors Q1, Q2. You can see this is part Q1, Q2. Then along with the part 2 capacitors C1, part C2, then you can find actually part the 4 resistors R1, R2, and also RC1, RC2 here. Okay. So here you can find, okay. So here you can find also the two transistors like Q1, Q2, BJTs, Q1, Q2, one capacitor, and also four resistor RC1, RC2, R1, R2. The output of the first circuit taken from the first collector terminal Q3 here. Okay, okay, okay. So these are the first some of the features of the first stable multivibrator, also known as part one shot multivibrator. There is only one stable stage. Okay, stable state. It produces a single output pulse. Then it requires two transistors, two capacitors, and a few resistors. It is commonly used in timing circuit, delay circuit, and also there's a part pulse with a part modulation circulator. So then you can go to for application used in regenerating weak signal, used in pulse generator, used in part memory actually. So advantages are there. You can find the part many advantages, and also the part disadvantages you can part read out here. Okay. Now I'll go to the part that of the part bistable multivibrator. As like that of the astable part multivibrator, the bistable uh, vibrator, astable part monostable vibrator, we have the part bistable vibrator. So a flip flop of the part one basic. So this is part flip flop or a bistable multivibrator is circuit with the two stable states that can be already part exist indefinitely. That is one and part zero actually. A signal from the outside causes it to change from one stable conduction to that of the another, and circuit will stay in the stable and stable until the part another trigger signal enters. A bistable multivibrator typically produces a square with the part separate voltage developed at a part output waveform here. Okay, so this is the part about the part. Uh, your circuit or the part circuit and the part that's the part multivibrator here. Then I've just for written up the part same thing here. You can read. So these are the part some features, like it is a part input known as flip-flop multivibrator. It has a two stable state and can remain in either state indefinitely without any input signal. It requires two transistors, two capacitors, and few resistors. It is commonly used in digital circuit as memory element, latch or flip-flop. It also used in application where a simple on-off switch is part required. Okay, and the part application may be for changing the supply of the two circuit and used for digital operation. Okay, in computer. So now I'll go to the actually part, that is DAC, digital to analog conversion actually. Okay, hello,
Yes, sir.
yes,
Yes, sir. Digital to analog converter.
okay. So now you can see also part DAC and also the part CAD. Okay, I means part ADC, part SCD actually. So a digital analog converter converts a digital input signal to that of the analog. That means 1 and 0. We can when you can apply the part any input, we can get the part analog or a continuous output here. So the digital signal is represented with a part binary code like 1 0, which is a combination of 0 and part 1. And this actually discussion will discuss about how digital to analog conversion takes place here. Okay. Okay. So this is the part block diagram, and a digital analog converter basically consisting of a part number of part binary input here, okay, and a single output. And in general, the number of binary the input of a DAC will be power of the 2, that means 2 to the power 0, 2 to the power 1, like that. Okay. Now this is the part the simple the circuit or the DACs are basically two type, like a weighted resistor DAC and also R to R ladder ladder digital to analog converter. Okay, so this is called a part a weighted resistor, which is consisting of the part simple part op-amp. Okay, with the part the two different type of resistors that you can see 2 to the power 0 R, 2 to the power 1 R, 2 to the power 2 R, and each having a part, each is containing a part a binary digit. Okay, so weighted resistor DAC produces an analog output which is almost equal to that of the part digital input by using binary weighted resistor in the inverting uh, adder circuit. In short, a binary weighted resistor DAC is called as a part weighted resistor DAC actually. So the circuit diagram of a 3-bit digital binary weighted resistor is shown here. You can see this is the part circuit, and the bits of the binary number can have only one of the two value, either 0 or 1. And let the part 3-bit binary input, it may be part, if we can say 3-bit, that is B2, B1 and B0. And here the bit 2 and B0, B2, B0 are most significant, that is called MSB, and the least significant bit, that is a part respectively. So I can say this is the most significant bit and this is called the part least significant bit. And the digital switch is shown in the part above figure will be connected to that of the part ground. Okay, so here you can find this is a part connected to the part this non-inverting terminal. Okay, inverting terminal, and part ground when the corresponding input bits are part equal to 0. Similarly, the digital switch shown in the above figure will be connected to the part negative reference voltage minus VR when the corresponding input bits are part equal to 1 actually. And in this circuit diagram, the non-inverting input terminal of an op-amp is connected to that of the part ground. This is non-inverting terminal from the ground. That means 0 voltage is applied to the part non-inverting input terminal of the part op-amp. Here you can get the part 1 and here you can get the part 0. So accordingly you can get the part output here. Okay. Similarly, so these are the part some disadvantages of the part DAC, like the difference between the resistance value corresponding to LSB and MSB will increase as the number of bits present in the digital input increases. It is difficult to design more accurate registers as the number of bits represent the part in the digital input increases here. Okay, so these are the part simple that simple the disadvantage of the part DAC actually, and it is difficult to design more accurate register as the number of bit represents the digital input increases actually, because here only can get the part 2, that is B2, B1, B0, and the 2 inputs more input, that is most significant bit, and also the part lowest significant bit. Okay, now we are coming to part R to R. This is called the part a ladder DAC. Overcomes the part the disadvantage of the binary weighted register DAC. As the name suggests, R to R ladder DAC produces an analog output which almost equal that of the digital binary input by using the part R to R ladder network in the inverting adder circuit. So the circuit diagram of a 3-bit R to R ladder DAC is just shown in the part diagram. You can see here you can find B2, B1, B0, and other is also part the grounded here. Okay, and so the bits of the per binary number can have only of the two value, either 0 and 1, and the 3-bit input like B2, B1, and B0 here. Okay, So here the B2 and B0 denote the most significant bit, and the least significant bit is part respect. This is most significant, least significant, most significant, and this is part least significant. And the digital switch shown above will connect the ground when the corresponding input equal to be part 0 actually. Okay. Similar, the digital switches shown in the above diagram will be the part connected at negative reference voltage minus VR. Okay. When the corresponding input bits are part equal to part 1 actually. The advantages of this R2R over the part DAC is part the R2R ladder DAC contain only two values of the resistor, whereas R and 2R, so it is easy to select design more accurate resistor. This is one advantages of the R2R ladder. Then if more number of bits are present in the digital input, then we have to include required number of R2R that can be easily. So due to the above advantages, R2R ladder DAC is preferable over the part binary weighted resistor DAC actually. Okay, so this is the part all about the part DAC. There is weighted average DAC and also the part R2R ladder DAC here. Now, all we will be discuss actually here, go to the part actually analog to digital converter. Here you have converted, discuss about digital to analog. Now you can go to the part analog to your part digital here. Okay, that is called part ADC actually. Okay, now here you can find, so an analog to digital converter ADC converts the analog signal to the digital signal, and the digital signal is represented with a binary code which is a combination of both 0 and part 1 actually. So this is the block diagram. Okay, then you can find, observe the part in the figure. This part in the above figure you can find in the figure an analog to digital converter ADC consisting of a part signal analog input and many binary output here. There are two type of ADC, direct and also we can also part indirect type. So if the ADC performs the analog to digital conversion directly by utilizing the internally generated equivalent digital code for comparing with the analog input, then it is called the part direct type. All of you remember that when it converts directly by utilizing the internally generated equivalent digital code for comparing with the analog input, then it is called the part direct type here. Okay. Similarly, so counter type of the part. So this is called part the different type actually. One is called counter type ADC. A counter type ADC produces a digital output which is approximately equal that of the analog input by using counter operation internally. And this is the block diagram of the part counter ADC here. So which is basically consisting of a 5 block, okay, 5 block uh, clock, signal generator, counter, DAC, comparator, and the part control logic here. The working of a part counter type DAC part, the the control logic. You can see this is the part control logic here. Simple, resets the counter and enable the part clock. Here the part clock is for there. Okay, clock signal generator in order to send the clock pulses to that of the part counter here. Okay, when it is received, the start the part commanding the part signal, and the counter get incremented for by one of every clock pulse. So whatever the pulse coming to that of the part counter, then its value will be part in binary format, and this output of the counter is applied as input of the part DAC actually. Okay, so this is the part simple, the working of a part counter type DAC actually. Okay, now so this DAC actually uh, yes, so this DAC converts the part received binary input, which is the output of the counter, into an analog output, and the comparator compare the part analog value VA to the external input value of the part VI actually. Okay, then the outer comparator will be part 1 as long as part input voltage is greater than 1. So the operation mentioned in the above two steps will be counted as long as the control logic receives 1 from the output of the part comparator. And the output of the comparator will be 0 when VA is part less than that equal to part VA. You can see when VA is less than that of the part VA, we are getting actually equal to VA. So the control logic receives 0 from the output of the comparator, and the control logic disables the clock signal generator so that it does not send any clock pulse to the comparator. Okay. So at this instant, we can find the output of the counter will be displayed as the digital output, and which is almost equivalent to that of the part corresponding equal that of external analog input, that is the part VI. So depending upon the part that the input signal 1 and 0 compared that of VI which is less or equal, we can get the part here the digital output here. Okay. Now I'll come to the last part of the part. This your part syllabus means one is called microprocessor and the other is called the part microcontroller. So in this microprocessor, we will discuss actually that is the architecture of the part 8085 microprocessor with the part features and also applications, and similarly the part 8051 microcontroller. So this 8085 microprocessor is an bit is an 8-bit microprocessor, and which is get developed by the part Intel in the mid of the 1970, and it has the following configuration: 8-bit data bus, 16-bit address bus which can address up to 16 port kilobyte, a 16-bit program counter, a 16-bit stack pointer, 6 8-bit register arranged in pair like B, C, D, E, H, L, and it requires a plus 5-volt supply to operate 3.2 megahertz single phase clock. It is used in washing machine, micro oven, and mobile phone. This architecture of the part edge wiper consisting of the part several key components, including the part accumulator, register, program counter, stack pointer, instructor register, flag register, data bus, address bus, and control bus. And this is the part you can see the different functional unit of the part is 8085 microprocessor. One is called accumulator. Okay, so this accumulator it is an 8-bit register used to perform arithmetic, that is logical input output, load and store operation, and it is connected to that of the Intel data bus and also the part ALU. Okay, hello, hello, yes,
Yes, sir.
and here you can find uh, one is for arithmetic and for logic unit actually. Okay, so this is an accumulator, and here you can find also the part arithmetic logic unit, and this name actually suggests that it performs a part arithmetic and logical operation like addition, subtraction, and then multiplication, and also etc. on the part 8-bit data actually. Similarly, another is what is general purpose register actually. So there are 6 general purpose register like in the 8085 processor like B, C, D, E, H, and L, and each register can hold 8-bit data actually. So these registers can work in pair to hold 16-bit data, and their pairing combination is like B, C, D, E, and H, L. So so this is a part simple part a comparison between the part the different part the registers here. Okay. Now another is called program counter. So this program counter is a but also 16-bit register. Here you can find to store the memory address location of the next instruction. So whatever the instruction coming, this will be stored to be executed. And microprocessor increments the program wherever an instruction is being executed, so that the program counter point the part memory address of the next instruction that is going to be executed. Remember, this is a program counter. So where you can find 16-bit register, it can store the part data for execution in the part future. Similarly, the part stack pointer is also a 16-bit register work like stack, which always incremented or decremented by the part 2 during push and pop operation. Okay. Similarly, another is for temporary register and also flag register. So temporary register is a 8-bit register which hold the temporary data, arithmetic and logical operations. And in a flag register, it has the 5 1-bit flip-flop which holds 0 or 1 depending upon the result stored in the accumulator here. Okay. So these are the functional unit of the part 8085. processor. And similarly, another is part in interrupt part control, and the part serial input, output control, address bus, address data buffer, address bus, and the part data bus. So these are all are part actually. Uh, yes, these are the parts include the functional unit of the part is a microprocessor actually. Okay. Now, uh, this is I'm coming to the part 8085 microcontroller. Okay, and this is a part you can see is a microprocessor means this is a part simple of processing the part the different part input and whatever that we apply, and it can execute the part the required output. But microcontroller is the part first and the most popular microcontroller, that is MCS51, and the architecture basically consisting of the part the following unit you can see. This is also like that also microprocessor. The system bus connect all support devices in like CPU. The system bus consisting of 8-bit data bus, a 16-bit address bus, and a bus control signal. All other devices like the program memory, port, data memory, serial interface, interrupt control, timer, and the CPU are all are integrated together through the system bus. You can see this is the part simple here part, a architecture which is part nicely describe the part actually the 8085 part microcontroller here. You can see these are the part input the part 0 and the what this is external interrupts. Okay, so currently the part interrupt controller here. Okay, so here you can find all these are you can see these are part all are internal connector. This part one chip room. So this may be questions comes to a part like a part draw a block diagram for the 8085 controller with a different functional unit actually. Okay, this may be part comes a part a questions are short note or maybe part of a long question. Okay, so here you can find also part there is some applications 8051 microcontroller. So this controller it is used for the microcontroller is maybe part automation, is widely used in part automotive applications. There are part widely used in hybrid vehicle to control the part engine option. Similarly, medical devices, these convenient medical devices such as blood glucose and blood pressure monitors contain microcontrollers that display the measurements, engine measurement also, and sorry, energy measurement also, and also the part touch screen. That the part now you are very much active in the part this touch screen. So there is also part some microcontroller part actually used here. Okay, so now you can get actually so these are the part. I'm just part covering almost all part of the part year syllabus, which is part in our part the syllabus actually given to you. Okay, and one thing that you can get actually here. Just 1 minute.
Social media. Don't believe after social media.
Hello. Yes. So one more thing is there. Just we have to be talk about for sampling theory. Let me. Okay. Hello.
Yes, sir.
Uh, I think that if you can see a part actually, uh, what I call you the course content. I cover the part almost all part of the part this the course. Okay, and one is I would want to discuss actually sampling theory. 1 minute.
Sir, numerical problem will come from this course.
Okay, so one more is a part sampling theory is there. For those so this sampling theory that is yes, you can see this sampling theory here. Is the slide is visible now? Hello.
Yes, sir, it's visible.
Hello.
Yes, sir, it's visible.
Is
Sampling
this
theorem.
slide is visible?
Yes, sir, it is visible.
Okay. See, this is called the part sampling theorem. Actually, which is the part also the main one of the part actually the special electric circuit you can find. So actually this theorem particularly used in the part in signal processing. Okay. So sampling of the signal is simple a fundamental operation in signal processing because many signals may be come, then how you can actually process to get a proper feedback or proper output, that has to be seen. Okay, a continuous time signal is first converted to discrete time signal by sampling process. The sufficient number of samples of the signal must be taken so that the original signal is represented in its sample completely. That means when any number of the part output is part coming or the signals are coming, we must has to be part processed in such a way that so whatever the output signal that we are getting, so it must be part actually must be the this containing actually the part or return the part this input signal actually. Okay, so also it should be possible to recover or reconstruct the original signal completely from its samples. The number of samples to be taken depends on the maximum signal frequency present in the per signal actually. Okay, and sampling theorem gives the complete idea about the per sampling of the signal. And different type of samples are ideal samples, natural samples, and flat top sampling. Okay, so these are the per different signals that may be appear in a part in a processing. Okay, similarly we can find the sampling theorem may be first stated as a continuous time signal. So this is a theorem statement. A continuous time signal may be completely represented in its sample and recovered back its sampling frequency when frequency of the part sampling is much greater than that of the part frequency of the part modulating. Okay, here F is the part sampling frequency and FM is the part maximum frequency present in the part signal actually. So this is the part, the theorem that we can get. Okay, now so how can you prove this theorem actually? So to prove this theorem, let me consider a continuous time signal, that is xt, whose spectrum is S, the spectrum band limited that of the part maximum frequency FM hertz. This means that the signal xt has no frequency components beyond their part FM hertz actually. Okay, therefore this this frequency or that signal xt or x omega is 0 for the part omega greater than that of the part omega m. That is, I can write x omega is equal to 0 for omega greater than omega, and where omega is equal to part 2 pi fm here. Let xt be the part continuous time signal whose Fourier transform is given by part as a part xw. You can see xt get convert the part Fourier transform comes the part x omega, and this is the part symbolic representation, that is the part time function and the part frequency function here. Okay, now sampling of the part xt at a rate of frequency may be achieved by multiplying xt by an part impulse train, that is, let it small delta ts t. Okay, and the impulse train delta tst consisting of a unit impulse repeating periodically, okay, for every second ts, where ts is equal to part 1 by fs here. Okay, so when fs is greater than fm, we can see this is the part 0 and the part the different time, and this is the part delta ts. When you can increase that, it can maintain a part simple a constant value over the different time, and this multiplication results in the sampled signal gt actually. Okay, that means when you multiply this, we can get another, that is gt, and this is the part output actually. This is a part multiplier, and this sample signal consisting of the part impulses spaced every ts second, the sampling interval, and the resulting or the sampled signal may be written as part, you can see, or the output you can see gt is equal to xt delta tst. So this is we can get by multiplication of this factor with the sampling signal here. Okay, now since the impulse train delta ts is a part periodic, okay, signal of period ts, it may be expressed as a Fourier series. Okay, and the trigonometric Fourier series expansion you can find of impulse train delta ts is expressed as delta t is equal to 1. This is a part of Fourier series, that is 2 cos, if you may have to remember, that is 1 plus 2 cos omega st plus 2 cos 2 omega st plus 2 cos 3 omega t, like that. Okay, and where omega s is equal to part 2 pi t by ts, and which is nothing but a part 2 pi fs here. Okay, then you can find also here yes, you can find the omega is equal to is 2 pi by ts, 2 pi fs, and that is a part gt value. When you can substitute this value over here, you can get this value. So let g omega be Fourier transform of gt, and xt is equal to part of the Fourier transformation. You can get x omega similar to 2xt, and also 2xt plus 2 omega for 2 omega st, like that, and so on you can get. And therefore the time domain equation gt can be expressed as a part also xt delta tst here, which can be written in frequency domain as like this. Okay, so this is the part frequency domain, and that one is the part time domain. And now the frequency domain, we can add g omega is equal to 1 by for ts sum over n is equal to minus infinity plus infinity x omega minus a part n omega s actually, and which is clear that the spectrum in the frequency domain consisting of the part time domain repeating the part periodically with a period of the part 2 pi fs. You can see the how the part processing takes place in part processing the part signal actually. So to reconstruct xt from gt, we must be able to recover x omega from that of the g omega, and this is possible when there is no overlap between successive cycle of g omega, and this requires fs is part greater than that of the part 2fm, and sampling with the sampling time that is equal to 1 by f part fs here. Okay, and here you can find hence you can find ts is a part less than a part 1 by 2fm. Therefore, as long as the sampling frequency fs is greater than the twice than the maximum signal frequency fm, that is signal bandwidth, okay, g omega will consisting of a part non-overlapping repetitions of x omega, and xt can be recovered from its sampling gt by passing the sampled signal gt through an ideal low pass filter of the bandwidth frequency maximum frequency fm actually. Okay, so the thing is part there. Here we can process the part signal by different part processing through by time domain and also the frequency domain with the help of your part, yes, with the help of the Fourier series here. Okay, so this is all about your part, the sampling theorem, which is used or which is help or which is actually to get the part processing of signal in the different uh, uh, yes, in the different processing of the part signal actually. Okay, so this is hello.
Yes, sir.
Yes.
Yes, sir.
Hello.
Yes, sir. It's audible. Everything.
Hello.
Yes, sir. It
Yes,
is
sir.
audible.
Audible.
Yes. What's the telling? I'm not audible. Hello.
No, no, sir. It's
Voice is
audible.
not. Hello.
Hello, sir.
Hello.
It's audible. Hello,
Yes. Please tell me.
sir. It's audible.
Sir, actually, no, your voice is not audible.
Sir, ଶୁଣା ହଉଛି sir, audible
Go on.
thing sir. Thank you.
Okay. So I think that's we have covered the part, most of the part in the part in your course actually. Whatever things are there, I've covered the part maximum parts, and any more part is there, I may look it into tomorrow. Okay. Hello.
Yes, sir. Thank you so much.
So I have sent the part all this part PPTs to yesterday. Have all of you got it, na?
Yes, sir. We got it.
Yes, sir.
Yes. You got it, na?
We got it, sir.
Okay.
Sir, any book you recommend for electronics?
What? Tell me.
Sir, any book you are recommending for
I told on the
electronics?
part of first class. I think Ball State I have already part told you. So all these things are part actually in there in Ball State actually, and also became Meta.
BK Mehta and another name
Ball
you
State.
told?
Ball State.
Thank you, sir.
Okay.
Sir, please share today's PPT and PDF also.
Yes. Tell me not. So your voice actually not audible. Very slow actually.
Actually, he's asking
Sir,
for the
please
PPT.
share today's.
Yes. What really you are asking for PPT, na?
Yeah.
I'll give it sure. No problem. Okay.
So
Oh,
we
okay, sir. Thanks.
are
Hello?
over for the day, sir. Right, sir?
Yes.
Today we are over, right, sir?
Yes.
Thank you, sir. Thank you.
Okay. So okay, and tomorrow for one more class is there, so I may be put complete. Okay.
Bolstead, that spelling can you send, sir?
Hello.
That electronics book. Electronics book, that Bolstead, that spelling can you send, sir?
Yes. Let me see, and I'll send it. Okay.
Yeah, please, sir. Please.
Okay. No problem.
first copy of the first.
Okay. Okay. Thank you.
Thank you, sir.
Thank you, sir.
Hello.
Thank you.
Thank you, sir.
Okay. So I think that you may get almost all questions from this part. Uh, uh, Actually, just what I'm looking in a group actually that you are the first batch actually. Whether that you are getting all these things. I think all material also you got, and you have your exam is start from.
Sir, 19th June, sir.
Okay. 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 So you all read. Then I'll take one more class tomorrow. Okay. Yes.
Okay, sir. Thank you.
Okay. Thank you. Now you can leave. So have all of you seen the part your syllabus?
Yes, sir. Almost syllabus is covered, I think.
Okay. So let me see any part I have left, then I maybe also go for that. Okay. Okay. Thank you. You can now leave. Let me first share to all. Then okay.
भाई मैंने गुड इवनिंग आम जनवरी 2024 बैच रो हमर किछि अछि कि एमिति व्हाट्सएप ग्रुप की किछि अछि कि जोथे कि हमें किछि कंटेंट शेयर करिबार एक्चुअली मु ए क्षेत्र रे नुआ मते कि जणा नाही आ मो से कार भी कांटेक्ट ही नै फर्स्ट क्लास अटेंड करछि एटा जदि का पाखे किछि नंबर अछि हमर किछि ग्रुप अछि प्लीज कि शेयर करि परिबे कि मो संगे नंबर किछि